The A330 pneumatic system supplies high-pressure air for air conditioning, wing anti-icing, water pressurization, hydraulic reservoir pressurization, engine starting.
High-pressure air can be supplied from three kinds of sources: the engine bleed system, the APU, two external high-pressure ground power units. Note: wing anti-icing is not permitted when the pneumatic system is supplied by the APU bleed.
The pneumatic system is controlled and monitored by two bleed monitoring computers, BMC. There is one BMC for each engine bleed system. Both BMCs are interconnected, and if one fails, the other takes over most of its functions. There are air leakage detection loops installed in the vicinity of the hot air ducts in the fuselage, wings, and pylons. If a leak is detected, a signal is sent to the BMCs, which automatically isolate the affected area. In flight, the primary source of high-pressure air is the engines. Both engines' bleed systems are similar. Air is bled from two compressor stages of the engine: the intermediate pressure, IP port, and the high pressure, HP port. There is an HP valve which can cut off bleed air from the high pressure port. It is automatically controlled by the system. The high pressure section, HP, is only used when there is insufficient pressure from the intermediate output, IP, i.e. when the engines are at idle. Once the engine speed is high enough, the IP is sufficient, and the HP valve closes. The air extracted from the compressor then goes to a bleed valve, which acts as a shutoff and pressure regulating valve. Since the temperature of the bleed air is high, it passes through a pre-cooler before being distributed to the users. The pre-cooler uses cool air from the engine fan to regulate the temperature. Engine 2 has an identical bleed system. Click on the blue box to display the Engine 2 bleed system. Both systems are connected by a crossbleed duct. A crossbleed valve permits their interconnection or isolation. The APU can also be used for bleed air supply. This is usually done on ground for air conditioning and for engine start. However, APU bleed air is also available in flight. APU bleed air is controlled by the APU bleed valve, which operates as a shutoff valve. Should the APU not be available, two high-pressure ground power units can be connected. This completes the pneumatic system. We will now show you how system information is displayed to the pilots. The pneumatic system is displayed on the ECAM bleed page. Click on the diagram to display the ECAM bleed page. Information on the pneumatic system is displayed on the lower part of the ECAM bleed page. Note, we have shaded the upper part of the ECAM bleed page because it is related to the air conditioning chapter. This will be covered in a later module. Let's identify the system components on the ECAM page now. The IP and HP ports, the HP valves, the engine bleed valves, the pre-coolers, the APU bleed valve, the cross-bleed valve, and the high-pressure ground connection. The following information is also displayed: bleed air pressure, bleed air temperature, and engine identification numbers. Controls for the pneumatic system are part of the air conditioning panel, located on the overhead panel. Again, we have shaded those controls which belong to the air conditioning chapter. Each engine bleed valve is controlled by its associated push-button switch on the air conditioning panel. The APU bleed valve is controlled by its associated push-button switch. The cross-bleed selector enables the pilot to open and close the cross-bleed valve manually, or to let the system operate the cross-bleed valve automatically. You will learn to interpret all the indications and operate these controls in the normal and abnormal operation modules. You are doing the preliminary cockpit preparation. To better illustrate what occurs in the pneumatic system, select the ECAM bleed page using the ECAM control panel. Let's talk about the indications on the ECAM bleed page. The engine identification numbers are displayed amber because the engines are not running.
During the preliminary cockpit preparation, all white lights must be extinguished. With the engine bleed push-button switch in the lights out position, the bleed valves are automatically controlled by the system. Observe the symbology on the ECAM. The bleed valves are cross-line amber because they are fully closed with the engine not running. The HP valves are also automatically controlled by the system. They are displayed cross-line amber to indicate that they are fully closed with engine not running.
The bleed temperature is displayed in green. The bleed pressure is displayed in amber because no pressure is supplied. The ground high pressure connection indication is always displayed in white when the aircraft is on the ground. whether the ground unit is connected or not. You also have to check that the crossbleed selector is in auto position. Observe the indication on the ECAM. The crossbleed valve is displayed cross-line green because it is automatically closed by the system.
Since the APU bleed push-button switch is selected off with APU running, the APU bleed valve is displayed cross-line green, indicating that it is closed.
The next step during cockpit preparation is to switch the APU bleed on. We have already started the APU for you. Note, do not use APU bleed if ground high pressure air is connected. Switch APU bleed on. Observe the indications. The APU bleed valve is displayed inline green, indicating it is now open. The left side bleed pressure and temperature are displayed in green because they are in the normal range. The crossbleed valve is automatically opened. It is displayed amber during transit and inline green when fully open. The right side bleed pressure and temperature are now also displayed in green. As you have learned in the APU chapter, the memo APU bleed is displayed on the engine warning display. The next step is the walk-around. If ground high-pressure air is not required, you have to check that the high-pressure ground connection door is closed. Usually, APU bleed air is used for engine start. The pressure displayed on the bleed page is also indicated on the ECAM engine page, which will be explained in the engine chapter. You are ready for engine start. To start both engines, click on the engine. Notice that the engine identification numbers have turned white, indicating that the engines are running. The engine bleed valves remain closed because the APU bleed valve is open, and the APU has priority over the engine bleed. Now you may switch off the APU. Switch APU bleed off. Observe the ECAM. The APU bleed valve is closed. The crossbleed valve is automatically closed. It is displayed amber during transit. The engine bleed valves and HP valves are displayed inline green because they have been automatically opened. We will now switch off the APU. Click on the APU master switch. With the APU master switch push button in the off position, the APU bleed valve is no longer displayed on the ECAM. We will now talk about the changes that occur in the pneumatic system during takeoff. Note, normally the ECAM engine page is displayed for takeoff. For training purposes, we will display the ECAM bleed page. As engine thrust is increased, the pressure delivered from the intermediate pressure stages is sufficient, and the high pressure valves are automatically closed accordingly. As soon as the aircraft lifts off, the ground high pressure connection indication disappears. Remember that it is only displayed on the ground.
During flight, you may need to switch on the wing anti-ice system, which uses hot bleed air from the pneumatic system. Observe the indication on the ECAM bleed page when the wing anti-ice is used. Note, for further information, refer to the Ice and Rain Protection chapter. Wing anti-ice is not permitted when the pneumatic system is supplied by the APU bleed.
Let's now see what happens in the pneumatic system when you are back on the ground. The ground high pressure air connection indication is displayed. With the engines at idle, the high pressure valves are automatically opened. When the APU is started, the APU bleed valve is displayed. Just before engine shutdown, we select the APU bleed on. Observe the indications on the ECAM. Select APU bleed on. The APU bleed valve opens. The engine bleed and high pressure valves are automatically closed because APU bleed air has priority. The cross bleed valve automatically opens in order to let the APU supply both sides of the pneumatic system. It's now time to shut off the engines. Click on the engine to shut off both engines. Observe that the engine identification numbers turn amber because the engines are not running. Before leaving the aircraft, we will shut down the APU. But first, we must switch off the APU bleed. Switch APU bleed off. Observe the indications. The APU bleed valve is closed. The bleed pressure is displayed amber because there is no pressure supplied. When the APU has shut down, the APU bleed valve is no longer displayed. This completes the normal operation of the pneumatic system. We will now discuss the indications associated with ground high pressure air supply. Click on the forward arrow. If the APU is inoperative for bleed air supply, a ground high pressure air unit can be connected to provide pneumatic pressure for engine start. The ground unit's pressure and temperature are indicated on the ECAM. Notice that in this case, the crossbleed valve remains closed with the crossbleed selector in auto position. In order to start engine 2 first, you have to set the crossbleed selector manually to open. This is done according to the procedure in your FCOM. We will demonstrate an engine 1 bleed fault due to an overheat condition. Let's assume you are the pilot non-flying. You are in cruise flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The engine 1 bleed system has failed. On the bleed system page, which has been called automatically, the bleed air temperature is displayed in amber because it is abnormally high. This is the reason for the failure. Click on the forward arrow and observe the ECAM bleed page. The bleed monitoring computer detects the overheat and automatically closes the engine 1 bleed valve to protect the system. With the valve closed, the bleed pressure falls to 0 and the temperature decreases. The engine 1 bleed system is no longer available. After review and confirmation from the pilot flying, clear air. Notice that the engine 1 bleed push-button switch fault light remains illuminated, even though the temperature is now within limits. This is because the BMC considers the engine 1 bleed system faulty and keeps the engine 1 bleed valve closed until a reset of the system is done. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. Observe the ECAM. The cross-bleed valve is displayed amber during transit and inline green when fully open. The pressure and temperature values for the left side of the system are back to normal because now both sides are being supplied by engine 2. After review and confirmation by the pilot flying, clear air. If you need to use wing anti-ice, you will have to switch off one air conditioning pack. We will deal with this fact later. In the inoperative systems column, engine 1 bleed is listed. After review and confirmation by the pilot flying, clear status. ECAM action completed. Now we will see what happens if you have to use wing anti-ice with the engine 1 bleed still inoperative. Let's assume you encounter icing conditions during the remaining part of your flight, and you decide to switch on your wing anti-ice. Switch wing anti-ice on. The engine 1 bleed fault procedure is automatically recalled on the engine warning display, and the ECAM procedure requires that you switch pack 1 off. This is because one engine bleed system is not sufficient to supply wing anti-ice and both air conditioning packs at the same time. Note: for more information about the packs, refer to the air conditioning chapter. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. After review and confirmation from the pilot flying, clear air. On the status page, Pack 1 has been added to the inoperative systems column. After review and confirmation by the pilot flying, clear status. ECAM action completed. For training purposes, to teach you more about the pneumatic system, we will continue by adding another failure to your previous configuration. This will be a left wing leak. This does not seem to be your lucky day. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. On the system display, the ECAM bleed page is automatically presented. On the air panel, the indications from the previous failure remain unchanged. The title of the failure indicates that a bleed leakage in the left wing has been detected. The left side of the bleed system has to be shut down in order to prevent any damage from leaking hot air. The first line of the ECAM procedure requires you to switch the crossbleed selector to the closed position. With the selector in auto position, the crossbleed valve would have been closed automatically, but remember, you have opened it manually in the previous procedure. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. Observe the indications. The crossbleed valve closes. The pressure of bleed system 1 returns to 0. Since there is no hot air supplied, the left wing anti-ice valve indication becomes amber. The wing anti-ice indications will be explained further in a later module. Continue ECAM action. No. Press the wing anti-ice push button switch. The wing anti-ice was switched off because you do not want to de-ice one wing only. The ECAM advises you to avoid icing conditions for the remaining part of the flight. After review and confirmation from the pilot flying, clear air. The status page also informs you that you have to avoid icing conditions. The wing anti-ice has been added to the inoperative systems column. The engine 1 bleed and pack 1 remain from the previous failure. After review and confirmation from the pilot flying, clear status. ECAM action completed. We will now briefly look at several abnormals, without performing the procedures, to see the remaining indications of the pneumatic system. In normal operation, when you use APU bleed, the crossbleed valve automatically opens. If it fails to open, an ECAM caution is triggered, and the crossbleed valve is displayed crossline amber to indicate disagreement. Conversely, if the crossbleed valve fails to close in automatic mode, e.g. after the APU bleed has been switched off, it is displayed inline amber accompanied by an ECAM caution. Accordingly, the engine bleed valves and the HP valves are displayed amber if their position disagrees with the normal position.